By being a standardized format that we can use to see the data in our data lake and a standardized interface to that data, Iceberg enables an ecosystem of query engines. All of the compute muscle now, we get to have lots of different approaches to that comply with the Iceberg API. So we've got our storage here, our format, we can all agree on what that looks like, and 1,000 flowers can bloom in terms of how to do the querying and what features to innovate in the compute plane. So really a pretty cool thing that this ecosystem can emerge on top of Iceberg. And we see all the different niches that have emerged here. Data scientists working with fairly static data might prefer PySpark. Teams working with streaming data are going to use Flink. Analysts might write queries with Trino or Dremio or something like that. All of them are seeing consistent data through these different tools simultaneously. No copying, no extra ETL between systems, no format conversions, really a full ecosystem with lots of different options that can all exist simultaneously. Now there's Apache Spark that I think has been doing this for the longest and seems to have the most mature integration, full support for reads, writes, its version of streaming, table maintenance, time travel. Netflix uses this. They use it at petabyte scale with open source Apache Spark and Iceberg. Performance is rumored to be very good with vectorized reads and smart pruning and all the gang, all the important things we want to see in the leading edge. Flink brings true streaming to Iceberg. You can do real-time stream processing and output a Flink job into an Iceberg table. Critical for some real-time analytics use cases. You can stream change data capture events from databases directly into Iceberg tables with ACID guarantees, and maybe some processing along the way. Dashboards show data that's just seconds old, not minutes, not hours. For interactive SQL, you've got choices. There's Trino, which really excels at federated queries. You can join Iceberg tables with data in Postgres and Mongo and kind of whatever. That's Trino's whole story. There's Presto for kind of Facebook scale workloads. There's Impala that gives you sub-second queries for dashboards. And they all support Iceberg natively with features like partition pruning, predicate pushdown, even time travel. The key is they're all reading the same Iceberg metadata, so you can pick the right tool for each use case without moving your data. Cloud data warehouses are embracing Iceberg as well. Snowflake can query and write Iceberg tables. No import needed. BigQuery treats Iceberg as a first-class format. Athena has full DDL and DML support for Iceberg. So if you're using managed compute, if you're using systems like that, it's a choice that you make. You can keep data in open formats, and that gives you more options going forward. Your data stays portable. And Iceberg isn't just for SQL engines. In a previous module, I showed you a tiny little bit of Python code. Well, that's PyIceberg, gives you native Python access without Spark, PySpark, or anything like that. You can read Iceberg directly into pandas or Arrow data frames. That's great stuff for a lot of data science workflows on batch data. There's a Rust implementation that's emerging for high performance applications. There's a Go library in development too. Not every use case needs a distributed engine. Sometimes you just want to read a partition into a Jupyter notebook or query Iceberg from a microservice. There's a rich ecosystem of specialized tools. You've got a Kafka Connect connector that'll sync directly into Iceberg for event streaming. If you're using Kafka, you probably want to take a look at Tableflow in the next module, which is a much more sophisticated version of that same basic idea. Airflow has got operators for table maintenance. Other orchestration frameworks support Iceberg. Jupyter works with PyIceberg. Iceberg fits into your existing workflow. You don't have to re-architect things. If you're using Iceberg, probably whatever tool sets you're using, you're going to be able to see an integration happen. That's one of the advantages of being the emerging standard. Open standards always give you flexibility. You're not locked into a vendor or an engine for doing your compute. Are you using Spark on batch data today? You can switch to something else tomorrow. You can run different workloads with different engines depending on different parts of the organization, their needs. And new tools will support Iceberg because it's the standard. And that's why people are at this time really going all in. So check out your current stack. Iceberg is probably already really well supported within whatever you're using.